Molded case circuit breakers are commonly used devices for low-voltage circuit protection. They're available in a wide range of sizes and ratings and have many applications. Molded case circuit breakers are normally used where a resettable circuit interrupting device is needed. In this program, we're going to look at the major components of molded case circuit breakers, identify the 4 trip elements used in molded case circuit breakers, identify 4 commonly performed tests on molded case circuit breakers, and discuss generally accepted guidelines for working safely with this type of equipment. While there are many different types of molded case circuit breakers, they all have the same main components: a molded case, an operating mechanism, arc extinguishers, contacts, trip elements, and terminal connectors. The function of the molded case is to provide an insulated housing to mount and enclose the circuit breaker component. The molded case housing also protects personnel from contact with energized components in the breaker. The operating mechanism provides a means of opening and closing the breaker. This toggle mechanism is the quick make and quick break type. The speed with which the contacts snap open or closed is independent of how fast the operating handle is moved. The operating mechanism handle will show whether the breaker is on or off. If the breaker has tripped, then the handle will be positioned midway between the on and off positions. Arc extinguishers dissipate the large amount of energy created when high current or short circuit fault is interrupted. Arc extinguishers usually consist of specially shaped steel grids isolated from each other and supported by an insulated housing. When the contacts are opened, the arc drawn induces a magnetic field in the grids, which in turn draws the arc up into the grids. The arc is then split into a series of smaller arcs and extinguished. The primary function of the arc extinguisher is to confine, divide, and extinguish the arc drawn between the breaker contacts each time a breaker interrupts current. The trip element on a conventional breaker uses bimetallic and electromagnets to provide overload or short circuit protection. This type of protection is called thermal magnetic protection and is an industry standard. Let's look at both the thermal and the magnetic operating positions of the trip element to see how they work. Thermal trip action is achieved through the use of bimetal strips heated by the load current. A bimetal strip consists of 2 strips of dissimilar metal bonded together. Each strip has a different thermal rate of heat expansion. Heat, due to excessive current, will cause the bimetal to bend or deflect. The metal having the greatest rate of expansion will be on the outside of the bend curve. To trip the breaker, the bimetal must deflect far enough to physically push the trip bar and unlatch the contacts. Magnetic trip action is achieved through the use of an electromagnet in series with the load current. When a short circuit occurs, the fault current passing through the circuit causes the electromagnet in the breaker to attract the armature, initiating an unlatching action, which causes the circuit to open. The only delaying action is the time it takes the contacts to physically open and extinguish the arc. This action can take place in less than 1 hertz, or 16 thousandths of a second, and trips the breaker instantaneously. Thermal magnetic trips are best suited to the majority of general-purpose breaker applications. They trip with time delay, where an overload occurs, but trip instantly on heavy short-circuit currents. The final component of a molded case circuit breaker is the terminal connector. The function of the terminal connector is to connect a circuit breaker to a desired power source load. Conductors of dissimilar material should never be intermixed in terminal or splicing connectors, where physical contact occurs between the dissimilar conductors. OSHA requires those terminals to be torqued to the value specified on the label of the conductor. Molded case circuit breakers should be tested periodically to ensure that they're operating properly. Testing should only be performed by qualified and trained personnel on circuit breakers and equipment which are de-energized, disconnected, and isolated. There are 5 types of tests performed on molded case circuit breakers. These are the insulation resistance test, the contact resistance test, the overcurrent trip test, the instantaneous trip test, and the rated current hold-in test. An insulation resistance test is used to determine the quality of the insulation between adjacent poles of a circuit breaker and from its poles to ground. The resistance test is made with direct current voltage to determine the actual resistance of the insulation. The more common method uses a Megger-type instrument. An insulation resistance test is made between line and load terminals of individual poles with the circuit breaker contacts open, between adjacent poles and from poles to the metallic supporting structure with the circuit breaker contacts closed. This test may be performed with the circuit breaker bolted to a metallic base, which simulates the in-service mounting. The contact resistance test is designed to detect high contact resistance across the breaker pole with the circuit breaker contacts closed. It's usually recommended that this test be made with a direct current equal to the continuous current rating of the circuit breaker. However, currents for the larger circuit breakers may be rated at 100 amps or more. The readings through each phase are measured and compared with the manufacturer's specifications. The overcurrent trip test is performed on a molded case circuit breaker to verify the time current characteristics, or inverse time, of the device. To avoid false test data, you should space any repeated test on any poles by at least 20 minutes. Space test on adjacent poles by at least 5 minutes. Use test cables that are 4 feet in length and of the same size as that of the breaker rating. If the times between tests are shorter than what is recommended, then subsequent tests will indicate faster trip times. If the time intervals between these tests is too short, then the circuit breaker may not have enough time to return to ambient air temperature, which could affect the accuracy of the test data. The instantaneous trip test is intended to simulate short circuit conditions. In field testing, not only is it important to determine that the magnetic trip feature operates properly, but it's also important that it trips at or near the instantaneous set point. Testing of the instantaneous magnetic trip feature may be by the run-up method or by the pulse method. With the run-up method, one pole of the circuit breaker to be tested is connected to the test equipment. The current control is set at one point where approximately 70% of the expected tripping current will flow when energized. The power is then turned on and the current increased until the circuit breaker trips. The recommended time for increasing the power is between 2 to 5 seconds. Increasing the power too slowly may cause the current to trip due to the time delay element. Increasing the current too quickly may cause an erroneous current reading because the meter indication lags behind the actual current value due to meter damping. Caution: if the circuit breaker does not open within 10 seconds, the loading circuit must be de-energized to protect it from damage. The pulse method, if done properly, is more accurate than the run-up method, but it does require that the test equipment be equipped with a memory or pointer stop amp meter. The pulse method requires the following steps. Connect the circuit breaker to the equipment. Apply current in short pulses of 5 to 10 cycles. Increase the current on each succeeding pulse until the circuit breaker trips. Occasional errors do occur due to current offset. This distortion is known as DC offset or asymmetrical. A rated current hold-in test is an optional test that's performed only if there is a possibility that the circuit breaker is unable to carry the rated load. This test consists of mounting the circuit breaker in free air with its poles connected in series. All cables, including the series jumpers, must be of proper ampacity and be approximately 4 feet long. When rated current is applied, no tripping should occur if the circuit breaker is operating properly. There are thousands of molded case circuit breakers in use today. Used and maintained properly, they'll provide adequate protection for the equipment they serve.